So, in the video number 6, this is all about selection recipes. Before going to tell about theory about this thing, I just have a model which I've used previously also, and I just want to show what I am trying to explain in this selection recipe. Now, selection recipe is a concept which is highly used in industrial applications, which where we have a big assembly as a product. I just want to show. Let's follow the previous steps what we have done so far. We'll just create one model. A new FEM and a solution. I'll just go through. So this is not something which is of criticality. I hope if you have seen the previous videos, this will be easy thing for you. In the FEM, we'll do the 3D meshing of any type. So my intent is not to show you how to mesh. My intent to show you how the selection recipes work, why they are used, and what purpose they have. Okay. So suppose I apply some kind of a force on this body at this face. Okay, at this face I apply some force of any value. That's not significant for this video, but yeah, let's do it. And then on this face I put a fixed constraint. Okay, it's a simple application generally we'll be using for multiple applications. So this is one case. Okay, now for some reasons your designer came and the designer said, okay, no, we have to change some part. We have to, since vibration design happened, that's why we have to make it more stiffer, so we have to add some bases. And again, he has asked you to add additional base in the face of this thing. So just for the sake of discussion only, I'm just trying to make something. Let's suppose he asked you for base to be added in this design, and then this is the additional base you have. So as soon as you go to the FEM file, this FEM will automatically update. Okay, yeah, it will automatically update. But now once you comes to simulation, you will notice one thing, that your constraint, the fixed constraint, the load is there because that face we have not changed. That face is still there. But if you see, there's a mark on the fixed side that it does not have a face selection. And what that means is, again, you have to choose which face is a fixed face. Now, doing it is a easy job if you have a single body or single component. But if you have a big assembly where you have thousands of components, thousands of things, elements, where you have to make manual selection every time, this will be a difficult job. So, and this will be a time consumption of no use, and that is where the selection recipes kicks in. So first of all, the very first concept of the selection recipe is that it tries to capture the engineering intent. Let me explain. So suppose in a manual selection workflow you are going, and then you told the software that this is a face you have to choose. So what it will do, face number 15 is selected. You applied some load, and then you modify the face. And as soon as you modify the faces, the nomenclature of the faces will change. The ID of the faces will change. The face number 15 will be something else now. And as soon as you do that thing, the selection will be lost, as we have seen in this case, this existing case. Okay. Now, how selection recipes work, rather than telling the software that you want to choose face number 15, you will tell the software that please choose a face whose name is load face. The selection recipe will name it. I'll tell you later in this video, probably in the next video, that how to do that thing. But to give you an insight first, I just want to explain this thing, that to initially you will tell, okay, to the software that please choose a face named load face and apply load on that face. So doesn't matter the geometry changes, if it updates, if as far as software is able to find that there is a face named load face, it will apply the load on that face only, and its selection will be retained. So you will preserve yourself from doing a tedious job of restructuring the model, reapplying the constraints, reapplying the forces again and again. So that is the first benefit of the selection recipe. Now the second benefit of the selection recipe is automation. Automation means if you have a single part or a single analysis you have to do, then you can go for manual selection. But if you have a product family, if you have multiple design iterations to do, if you have multiple optimization study to do where your face is changing multiple things, then it will be difficult for you to do a manual selection every time. Consider this model of an engine, what we have done here. What we can do is, you can automate things by giving a nomenclature. So what you're doing, you're not choosing the geometry now, you're choosing the intent, engineering intent behind it, because that is the only thing that does not change in a model. Okay, the load phase will always remain load phase, the symmetry phase will always be symmetry, the mounting phase will always be a mounting phase, and etc. So the idea is not to choose geometry, the idea is choose to engineering intent behind it. So yeah, this is the second application, second reasoning why we should go for. And if you have to automate these things, you have to go with a consistent naming of it. So as soon as you make a product, you simply have to name it. Suppose this is a load phase, you mark it, this is a load phase. Even though your model changes, as far as your model is able to find a phase named load phase, it will apply load on that part. Okay, so this is the second reason why this is heavily used in industries. And the third reason why this is used is robustness. Robustness is means you're not trying to solve a model of today. You have a today's model, it will survive today's conditions and cases, but there will be multiple design iterations, multiple studies, and your model will be changed. There will be a CAD revisions, the revision A, the revision B, the revision C, and your idea is, because you're always improving it. Now your idea is to make your assembly, make your simulation consistent with the CAD model, and make sure that your model is capturing everything, in doesn't matter which revision. Okay, so if you're following the manual selection, it will be it's going to be a very difficult. Rather than, what we can do is, you can take a CAD revision, so, you can take a phase, and then you can name it as a load phase or a fixed phase or anything, doesn't matter. And it does not matter how many revisions you have, you just have to change that thing, and as far as the system is able to find that phase ID, it will be applying that. There are multiple ways, I'm just naming phase IDs, but there are multiple ways you can use this thing. So how it will help is, first of all, it will reduce your simulation time to almost 50-60%. The loads will be automatically updated, the constraints will be automatically updated, you will have less work, reduced work actually, and you can go through the faster design iterations. You don't have to rely upon every time setting up the system. Okay, so for this simple example, let me do one thing. Let me create a simple selection recipe. Okay, so I'll do one thing. I'll just go back to the previous model where we have applied this phase. Okay, just remove this thing, existing part, sketch and all. Okay, so let me select this phase. I'll go to the polygon filter, polygon phase ID, and go to the phase, and then you can go right click and go to the properties of it. In the properties, there are multiple ways you can traditional or bulk edit form. You can I'm going for traditional, and there's a title here. You have to be cautious. You have to write it. It is case sensitive, so you have to write that way. And I am applying load phase. Okay, and giving ID1. You have to give some random IDs, and for some reason you have to press tab button, and then this check mark will come, and then click OK. Okay, so this phase, if you go and right click properties again, you will see there's a load phase which is having value 1. Okay, now this phase, in the same way, I'll apply as a fixed phase, and I'll give a value 2. Okay, again you have to press tab and then click OK. Now this part is done. This part is done for me. Now what we have to go do is, we have to go to the FEM. Okay, let's do one thing. Let's select the body also. Rather than in the doing meshing also, this will be working. So in the face option, we'll change it to the solid body and choose this body, and right click properties, same way, body, and 3, and click OK. Now in FEM, if you see, there is an option called selection recipe. I'll go to right click and write new selection recipe. Now there are multiple ways you can make selection recipes, as a single label, as a bounding volume. I'll tell you later these things. I'm right now going with the attribute. Okay, so we are choosing entire model, and entity type I'm going to choose, first of all, polygon face. And then what we have to do is there is a name here, so I'll go and add attribute. Okay, now first of all I have to write the name of it. So I think okay, you have to go for user attribute. This name I'll delete it, user attribute, and then you have to, yeah, you have to go for a string, and then the title we have to give us load phase and the same value 1. Okay, for some reason press preview if you want, and it will show you this phase. So if you see this selection recipe, okay, I have to name it first of all. This is the phase, it will show if you double click it. Okay, so I think I have messed up things. I'll just do it everything once again. We'll go to selection recipes, new selection recipe, and then go to attribute. I'll name it load phase. Try to be consistent with the naming. And then in the model, we have to choose the polygon phase and then go for a user attribute. I'll click OK. And then in a type, we have to go for a string. In a string, we have to go for load phase and the value 1, which we have chosen previously, and click OK. Now, similarly, we have to go for a new selection recipe. Same way, there's a fixed phase, polygon phase, user attribute, click new. And then in this thing, you have to go for a string and you have to go for fixed phase, and the value you have to do 2. Okay, and it will highlight that part. And the third thing we have to go for is the body. So here in the entity, we have to go for polygon body, and again user attribute, and in the string, and we have to go for body number 3. Click OK. So I will delete this collector in the mesh. What I'll do is I'll mesh it using selection recipe. So it will ask for selecting the bodies. I'll choose the body and click OK. Okay, it will automatically choose that thing and do that thing. Now this selection recipes will be carried forward. All right. So as soon as you go to this simulation file also, you will find this selection recipe and it will tell you the source of it, where it has come from. If you make it, it will be coming like this: load phase, fixed phase, body phase. And if you have not made it in that file, it will come like load phase from model 1 FEM2 file, which is the same model. So it will tell you from what is the source of behind it. Okay, now I'll delete the existing constraints and the loads, and we'll try to apply the loads and the constraints using selection recipes now. So I'll choose load type as force. Where to apply, I'll say load phase. Sorry, I have to choose selection recipe as a filter and apply load phase as an option. Then apply 1000 newtons and then apply in the y direction. I'll apply in minus y direction. Okay. It will automatically take that thing. And then we have to go for a fixed constraint. Again, from the filter menu, I'll choose selection recipe and then go for a fixed phase and then click OK. It will automatically apply this thing. And this is the benefit of it. So initially it might look like a tedious job, but this is going to be so worthy if once you see how it behaves. Okay, so let's see. I'm gonna do the same operation here again, and what we'll do is I'll make changes in this space. I'll change this space and put this thing as a rectangle. I'm trying to add a base on this thing. Okay, and then additional thing. Now I'll just to show you, I'm just going through this thing and I'll show you the selection recipes will still be at that phase or not. So fixed phase, if you see, it will show you there is no selection entities in the selection recipe because the phase is lost, the phase ID is lost. Okay, and same thing it will show here, and same thing it will show in the constraints as well. Okay, there's no fixed constraint. What we'll do here, we'll simply go. We don't have to do anything. You simply go. You again choose a face. Click right. Properties. Same procedure what we have done in Simcenter. Apply fixed face and then give serial number to what we have given previously. Okay. Click it. And as soon as you go in the FEM file now, it will ideally it should, yes, it will find there's a fixed space. Okay, update that thing. There's a fixed space here, and then you will go to the simulation file and you will find that there is a already a constraint applied. So this is the purpose of the selection recipe. Okay, so I mean this is going to be so beneficial if you are going to use it wisely, if you want to survive the CAD changes. So there are three things you have to remember. First of all, you are trying to capture the engineering intent rather than selection of the geometry. Second thing, you want to automate the process, and third thing, you have to make sure that the model is robust. So you just remember these three slides. You want to take a snapshot of this thing, it's fine. Why we are doing this thing. The second thing is the engineering intent of it, and third thing is why the industry is using that thing. All right, see you in the next video.